Thank you so much for joining. We have folks from the DC Metro Rockville area. John, you're in Florida?
Yeah, beautiful, sunny, safe Lighthouse Point, South Florida.
Yeah, you have rubbed it last time. You're rubbing it again. I will take it. But guess what? The folks on the other side, Chandra and Joby, they are also in a beautiful weather in Abu Dhabi.
I know exactly. I get it. I thought they would smile.
Anyway, I'll make it quick. I'll introduce Chandra and Joby, and then I'll give it to Gary. So again, I think you all know me. Maybe for Kyle's sake, I'm Krishna, Krish Yandluri. I'm based in the DC metro area. Uh, Over 25, 30 years of technology transformation, entrepreneurial experience. Have known Gary for a little while. Um, and Chandra is a good friend of mine. He's based in Abu Dhabi, Joby as well. Um, and they are in the technology space, transformation space. Chandra is actually in multiple spaces, but Joby mainly is at the cusp of all things cyber, AI, robotics. He heads up a major company's IT department. They are both in Abu Dhabi. They've traveled quite a bit, known very well. They are connected in the UAE market, whether it's the government, private sector, and all. So anything that's cutting edge, they'd like to, look into. And for sure, when Gary said, especially about the cyber crucible and all, I thought it was a great intersection of all things coming, AI. And John, your eyes are already set in post quantum. I think there will be an opportunity to talk about that later.
Yeah,
But before I give it back to Gary, Chandra and Joby, anything you want to say?
Thanks, Krishna, to arrange a meeting over here. The
Okay.
first point itself, I am impressed. Cyber defense.
Yeah.
yeah.
If you are putting cyber offense also, I will be very impressed because offense is some part of defense.
Yeah, so
Okay.
we do have a whole solution around this that we actually have some middleware and do things with it, and then have an AI backing. But we're gonna stick to the point of the spear. Like this is what allowed us to build around it. And then we made a demo for you. We recorded it last night, and as we were turning on the computers this morning, we smelled smoke. So I didn't catch all of it quick enough to put it back in. So I've got a recording. I got all the pieces. I'll get a new computer tomorrow if you really want to see us do it live. But so I want to show you though. I think the meat and potatoes of the control and the visibility that we get in memory, and then we can kind of move around to what that means and how it literally removes the Windows risk profile from your environment. Does that sound
Fantastic.
fair?
Mm,
Yeah, that sounds
great.
that sounds good. Good
Yeah.
job.
Uh,
Yeah.
Yeah.
Okay. So John, before we start, let's just
Yeah.
a quick intro here as well. Gary Simba. I'm the President CEO of Vertical Engineering Systems. So we are a cybersecurity company, and we partner with John in this team as well. So part of our core competence is really around anything cybersecurity services, whether it's assessments, pen testing, GRC, and some of these services that we're obviously going to present within Cyber Crucible and John here, and some of the other uh, um, services that we offer around compliance, readiness, again, any of the different regulatory assessments, IT management and mind services, and then AI innovation. So digital innovation and transformation is also kind of big core of our organizations, both combined here. So I'll let John take it away, that we can show you guys what we have, and then a quick intro, John and Kyle as well. Please.
Yeah.
Okay, great.
I can kind of do that real quick. I've spent a lot of time at manufacturers. I run security businesses around products. I got acquired a lot by our private equity, and I just didn't like it. So I was afforded an opportunity a couple years ago now, and I went out on my own, and I've been able to build a team and some IP, and I'm never looking back, right? Until you need to borrow enough money to where you get CPE. But right now, I'm enjoying those, being unsupervised and valuing people and outcomes over process for profit. Kyle's one of our senior dev. I call him our CTO, even though we're project
Mm,
based here a lot of time. Um, Kyle has a unique background of bringing products to market, as a dev and lead dev and CTO for the last 10 years. So when we saw this solution here, I kind of figured a couple different ways around how we could build on it, being as how it was a driver. And like, since 19, always the only way you troubleshoot a driver is uninstall it and reinstall it. And once it's on, it protects. Like, you have no reason to uninstall it. So I immediately fell in love after it took me a little while to like get out of that sense of I have to watch this thing, right? Like, it takes a while to get untrained from how the market has conditioned us for, cyber like resilience and things to fail, where as this is a defense solution, it doesn't fail, right? Like, it's lower in the stack, and I'll go into it, but I think that should get us going, Dr. Simba.
Yep, that's good. Yep, yep.
Okay, so we're gonna stick to the high level of the problem is that the system's rigged to fail. Like, they are herd immunity, signature based, meaning they have to have it happen. They're describing conditions, even if it's deep learned conditions where there's no rules to look for, there's still patterns. And pattern matching fails because you have to know what you're gonna match a pattern to connect. And so while these guys have grown so big that the pattern matching and the numerous ways they build the signatures are updating pretty quick, they still fail. The second thing is they don't live low enough in the application stack to actually see everything and stop everything, because they're a product. There's an application just like everything else. So the unique approach is, if you can get lower, like just like in football or anything else, low man wins, right? Where you have leverage, you're able to see everything. So out in the market space, what we're seeing is the hackers can move you. They're going to get through at least once. The more specialty and more crafted it is, the targeted it is, the more likely they are to win, right? Or they're just smashing and grabbing identity session tokens and things and running as quick as they can to get away from your EDR from figuring out their pattern, right? The other thing we really feel like in the market is, resilience sells subscriptions. No matter what you buy, pick a vendor, they come back next year with another AI subscription to help you see. They never solve the problem. They never go, we did this year. Are you happy with us? Great. Let's renew. They're always like, well, if you act right, we do this and do that. Their solution is never designed to stop and do one thing. This one is. This one is designed to stop the bad actors in memory all of the time on Windows devices. That you don't need to sell anything next year around it. It's going to do the same thing. And not only is it going to do it, it's not internet dependent, right? It's a driver. So it's a fully certified Windows compatibility driver. Excuse me. Meaning 12 times a year they go through life testing to get included in an update, right? Like, no degradation over X amount of time, no impact to the core operating system. None of these other AV vendors, and security vendors do this. This allows them to be low enough in the stack to stop identity theft, right? So we're talking crypto wallet session tokens. My favorite is to put it on my friends' machines with kids with those gaming platforms and watch how often they call the identity pieces of your OS to authenticate to see if you're cheating, or to just copy all your identity settings, because in 20 years your kids are going to be real people and they're valuable, right? If we were going to steal them. These type of thefts and in-memory thefts, these types of attacks and in-memory attacks, whether they're like targeted for cash, like ransomware, or info stealers, they all have a particular ask, right? They hollow out they hollow out libraries and then trampolinium bits of code. They do multiple trampolines to build a routine in memory, so they're signatureless, because they, no matter how they try, and when they do try, sometimes they break the world because their goal is not held to the same standard as something like this is. And then we can get into the targeted AI or the agentic AI problem that the driver entails, right? There's only 3 steps to this, and it has to do it under 200 milliseconds, right? It has to decide whether or not the memory, the behavior, the actor is legitimate, right? And it's easy to see a side call and stuff, because we could do it. We could go pull up my machine right now and follow out Notepad and open Word, right? Everybody's going to let me do it. It's an unmatched, unseen thing. Now, if I started bouncing code behind that, eventually they might see me doing something nefarious and kill me. But that's how hackers are getting into your memory, right? We're able to see all the analytics and decide if that memory, if that behavior is acceptable or not. And our criteria for acceptable is, does it go after the data? Right. That's the keys to the kingdom on your Microsoft investment. If we do decide it's negative, we have a couple options. We can hide or deny access to the data, and we can freeze it before the command is run, so we can see where it came from, do full preservation and analytics, and the hacker doesn't know that it's not finishing. They're sitting there waiting, right? It's not, they're not tipped off to, we're catching them and orienting on them, right? We're also not blowing up your user and telling them there's a hacker on your machine, because if the hacker were on your machine, they'll see the alarms and know it's time to get, right? So the whole approach to being a driver, being part of your system that hardens your memory, is built throughout their whole process, right? So when we just had, I started with decide and respond, but detection, so analytics, right? They do a couple of honeypot, a couple other things, but it's really a targeted AI on what argument is coming from, the parent, the task, the child thread. Is it going to touch memory, and should we let it do that, right? Any questions on this?
No, it's fine. We will ask the questions later.
Okay. So yeah, I kind of merged those two slides, or those two slides. There's a decoy blocks. We use analytics and telemetry to view what we see, and again, like we're so low. um Kyle might remember giggling, but I think they actually found like the Microsoft licensing algorithm in the kernel, where they're that low in their testing when they were doing new features. I was kind of told, and I was just laughing because, like, they go a long way to hide that from people, and if we can see that, then they can see everything, right? And I stress that visibility, these other telemetry tools are limited. They're not passing and logging it and extorting it from your system. It's all kept locally and thrown away. So this is really what that driver looks like, right? Couple different pieces, right? The crypto wallets were really easy because it's a nice piece of math you can match, right? Memory behavior we talked about, file telemetry module, and then the process behavior. That process behavior is really the key, right? Like, is this process calling to data, right? That's really what triggers the suspend or hide mechanism in the telemetry, or in the system. Very lightweight. It's not a real time. You don't have to, right? It's actually, when we say it's a defense, like it's an operational solution. It's like your fire suppression system. When it senses fire and conditions, it puts the fire out. It calls you and tells you, but it allows you to still work. It's not like these other ones where if it sees a fire or thinks there's a fire, it asks you what it should do, right? This is a fully autonomous AI driven solution. And again, here's the Windows compatibility program. It is, they put themselves through this rigor voluntarily, right? So that means they're 12 times a year they are going through compatibility testing, and when Microsoft makes a mistake, they have to do it again, right? It's not just subject to them; it's subject to being part of that environment. Where really what this means is we are faster, we require less touches, we are easier to deploy, and we require less maintenance, and we don't require internet, we don't require stats and updates. We can be fully independent, so you can run it in your SCADA environment and have no process or no performance degradation or efficacy degradation, with the caveat that if the machine runs out of space, it will run out of space to log, right? So, but that's a standard in any kind of program. But that's the only real constraint I've found with the solution itself. I really am going to harp on this again because Resilience sells subscriptions, and we're a defense solution, and we solve a problem. Nowhere in an XDR solution, EDR, MDR obligation do they say they stop the threat. they'll talk about where they can catch them and how they can catch them, but their maxim is we're gonna get beat. They've like duped the insurance industry, they've duped customers into accepting the fact it's accepting defeat. And I really can't explain it. Like I worked for years in orchestrating, it was a 5 continent, 150 site, follow the sun 24/7 operation, and I orchestrated it all myself. It killed me. Hackers magically have AI farms that could take over the world, but we can't figure it out when we own the whole network, right? So in my mind, there's a misconception about what we're doing and what EDR and the market is doing, and this product goes against that, right? It's literally attack initiated, attack stopped. I'm going to hammer one more time. Elegant. It's a driver. It requires some updates that it can or can't get from the internet. It'll phone home when it can. It does not require an extensive set of networks integration. It does not require each and every single one of these subscription fees to have higher, if not better, efficacy than whatever we're putting it next to. And I'm pretty sure there's 3 or 4 years of defeats of just any EDR vendor, AV vendor. Like, we're not saying you don't have to have it. We're saying give us Defender and we're going to outperform you. Let me say that again. We're going to take the one that everybody has to beat the other guy and have a higher catch rate. Am I misconstruing that, Kyle? I know you're key a lot of that thought. That's literally the value prop here that we can show in our demo, right?
No, absolutely. I mean, the main value prop is the fact that it is so low, like you hammered a couple times, and the behaviors that it looks for catch novel approaches rather than having to know ahead of time anything about it, about the attack, or have a patient zero, right? So that the entire value prop is that it's able to find new things before other solutions and stop them. Whereas other solutions, you're at best playing a catch up game once an attack or a specific threat actor or a specific indicator has been found in some whatever the sufficient number of machines or victims is, then they can issue a patch to say, okay, now we know about this. We can look for this malicious DLL or this entry point or this vulnerability. Whereas Cyber Crucible doesn't care about how they get in or what they're doing. It's looking at per process, per thread, per attempted execution, regardless of privilege, regardless of what process is doing it. It's absolutely it.
So, a quick question could be for John or Kyle. Now, it's in memory, not dependent on internet, but it's anything, it smells anything that's happening in the Windows network. Like, let's say it's for an organization, they are on a domain, right? They're on a, so it's not just protecting our machine, it's protecting the entire network or domain. That's question A. B, actually, let's answer that question. Then I'll go back
Sure.
to other operating systems. Yeah.
Sure. Yeah. So it is a per endpoint. So this would be deployed on each machine. It will look at things like network shares, like Active Directory, and things that the machine has access to, not just local drives, not just removable, things like this. But it is acting specifically on a per machine basis. It's not something that you would install in a rack or have like a network appliance. It is a driver that's installed in the kernel of the individual endpoints.
So you are going to deploy a kernel driver?
Yes.
So if the kernel driver got crashes or conflicts, how you can determine?
Yeah, so there are multiple answers. First of all, there are failure cases just in case of emergency to prevent like a boot loop or something like this. However, there is a lot of effort that Cyber Crucible puts in. You might be thinking of the CrowdStrike blue screen issue that happened last year, right? Where there's a lot of things that Cyber Crucible does specifically with their own testing and within the Microsoft. They call it the WHCP, which is the Windows Hardware Compatibility Program, or the WHQL, which is same program but different name. Windows and Microsoft require for this type of kernel driver, they actually require certification and testing to be done as if it was a hardware device, even though it's purely software. There's no hardware component, where they have to certify for every server and desktop operating system, every major version going all the way back to Windows 7 and 2008 R2 for servers. Every single functionality test. This requires that they do things like test with devices being hot swapped while running, with restarts happening during patches, with all the weird edge cases that Microsoft would require for certification, just like if you were developing a PCI card or something. So they go through all of this, as well as very, very rigorous systems testing internally, and have to pass all of these components to issue a new version. And then the new versions are also, when they're deployed, they are signature checked, hash checked, AD swapped, so that nothing is happening hot swapping at runtime. It's all happened at boot, and it's all done safely. And if an update fails for any reason, whether it's a drops network connection, a corrupt file, a test failure, anything like this, it won't be applied. It can also be optionally enabled or disabled with safe mode. So protections can be enabled in safe mode at the admin level or not, depending on if you want your safe mode, your UEFI settings to be covered or be like a failure state. And then there's also network-based uninstalls, and in case of emergency, local DLL deployment that can be done to uninstall in case there is any form of issue. So there's actually redundancies on redundancies for not only the testing and the certification to make sure that a crash will never happen in the kernel, but even if there was, there's many safety mechanisms in place. Like I said, this goes all the way back to Windows 7 and 2008 R2 for operating system support, all the way up to everything new. So all the tests are done for everywhere in between those and are required to pass before any functionality is added or changed or patched or anything.
So all the EDR solutions are getting kicked out of the kernel. We can't be.
Okay, great.
It's just a game they're playing to try to keep up hackers that's never going to win, right? And it's got vulnerability. What's the next one we can do for you? You got another question?
Oh, sorry.
No, for
Joby, you're good with that, or?
yeah, it's fine.
Okay.
Just have a look.
Yeah, you're talking mostly Windows, operating system. What about like iOS, or Chrome or Linux or Ubuntu? Any comments there? I know Windows is a lion's share.
So here's the this is the friends conversation. We're very conscious about trying to build that out. Cyber Crucible business goal is very focused on Windows. The differences in the operating systems make it very tricky, but we actually feel like we can help make that Mac and Linux side of the business available,
Got
right?
it.
Like it's not here yet, but we definitely have plans on driving that conversation.
That's it. That was it. Yep, a quick one. Go ahead, John.
Okay, so I think that's it. I mean, I've got some other slides on the pattern base, but I think we're all there. So I'm gonna jump into this.
In this video, we do show like MIP labels that have already been scanned and applied to files, and then a file with and without protected information in it, and then trying to upload it to, I think it's ChatGPT in this video, but Copilot, Claude, they're all treated the same by Cyber Crucible, and then after that is the ransomware piece. So this disk has files seeded all over it. Like there's images of birds here, just for the ransomware to potentially encrypt, just innocuous data. And then in the documents folder here, I have different types of files, some of which have MIP labels. You can see there's one called, MIP sensitive data, and then there's a copy of it called no data classification.docx. The no data classification one has no labels associated with it. It's just a docx without the protected information, and then the rest of them are actual information, right? Actual protected files. So we'll go ahead and in a second here start doing the live Cyber Crucible deployment as well, which I always like to show the live uninterrupted installation, because of course this is not like the most important thing to people. The protections are the most important thing, but deployment and how it gets on the network is obviously a big piece, because it's how fast can we deploy it, how many endpoints can we do at once, does it interrupt the users, all this sort of stuff, right? So waiting for the video here to go to the browser. Okay, yeah. So installation is very simple. It's a multi-tenant system. You select your group, your tenant within your tenant. There are scripts to deploy. There's a GUI. There's a command line interface, so it can be interactive or headless. I go ahead and run the PowerShell script here, but it can be deployed through any RMM, any distribution tool, SCCM or something like this, right? It can be done completely headless without interaction from the end user on the machine, without the end user seeing or doing anything. no reboot required, and protections are enabled immediately as soon as it's deployed. And we can see here the update or the download will take a second, and then it'll be done. And that's the entire installation process. There's nothing else to do, so it can be completely automated. I know for sure that Cyber Crucible has pushed out to 3,000 to 5,000 machines at once at one point during just an afternoon deployment, all at once, because there was actually a customer that was a large Northern African oil company that had a ransomware incident they needed to deploy immediately. And they deployed over one afternoon on a weekend to, I think it was 5,000 machines at once with no issue. Internet connection is obviously required to download the files and to do an initial check-in with the server for licensing and initial configuration, but that's it. Once that check-in is done, which you can actually see it appeared in the background of my browser there, that's it. There's no internet connection required at any point after this. Obviously, you want to update, you want to get alerts. Sure, you need network for that, but the functionality can work online or offline, including in a corrupted network state, which could be, hopefully you're not experiencing an attack, but if you are, maybe network connections, switches go down, things like this. Or in some cases, attackers, if you're dealing with a threat actor, will firewall off EDR servers and SIMs and things like this to prevent alerts from going out. Either way, Cyber Crucible remains functioning because it's all on edge on the endpoint. All of the learning, all the telemetry, everything happens right on the machine, all the way from the detection to the prevention to the reporting. And all of the reports in the telemetry are saved on the disk and protected themselves by the kernel driver, just like everything else is. So there's no tampering with any of the root cause or the initial timestamps or anything like this, right? John, if you can, is it paused or is it just...
All right, it was running. You just left it a second.
Gotcha. Okay. Again. Yeah. So then we'll probably skip ahead a second here to just be done with the installation process. Like I said, no reboots required or anything like this. And then, okay, so I go just pull up a task manager also to show that it's running and what the resource consumption is. You can see it's using almost no CPU. It's at 0%. Obviously, assume maybe 1%, something like this, depends on the machine. And the memory delta there is 0 and went even negative for a second. And then I show the working set, the actual memory in use, and it's, call it 28 megabytes there, right? Which obviously is barely anything. You can compare it even to things just in this list on this screen that are using much more and probably doing much less processing. The analogy I always use is that this is less memory than even like a Google Chrome tab or a browser tab with like a single, video or something in it. This footprint remains consistent even during attack, even during protection, right? The memory use by Cyber Crucible is one of their big selling points, where they are monitoring all of the actions, all of the memory tampering potential, any file handles, processes that are running, opening, accessing data, all of these things all at once, right? So I'll go ahead and go to my documents folder in this PowerShell, and I have this read MIP PowerShell script here that I'll go ahead and just run on a couple of these files to show with and without the MIP labels. And yeah, there, go ahead, John. Yeah, just to show that some of these files have MIP labels in them. You can see, as of this recording, these files were just dropped on the disk, so that timestamp is, yesterday local time here for us. And then there's.
Did you label them like just sensitive, or did you actually put, let's say, a date of birth or a social security number or something like that?
Yeah, it's fake data, but there is
data.
Data in here. Yeah.
Okay,
Yeah.
sensitive data in there. Okay.
Yeah. Obviously, it's not real PII, not real HIPAA data, things like this, but there's the same format, the same data, so that the classification finds it and then labels it sensitive and says like there is an MIP label in this file, right?
Crucible is labeling it. You don't need a separate process of labeling.
Cyber Crucible does the protections, but the securement platform that we sort of bundle everything together to work as one solution. That John, I'm sure you'll get into and want to talk at length about, right?
The securement platform is where the labeling, the whole data posture management, right?
So we're taking a DSPM of your choice, right? Or we have our preferred partners, and we're without a Microsoft subscription, because most people, they charge for E5, or you have to have a premium subscription to get the solutions to talk together. We're taking the MIP classifications and labels out of your DSPM of choice and putting them in your Microsoft environment. And then we're also rolling out Purview if you'd like it to around that. So we can
Perfect.
do complete data rollout on Microsoft and partner with, Defender, Endpoint Defender, CASB, right? That's the value prop that we're championing, right? Use what you got and stop, and actually put a defense in place that stops the bad guys, right? And stops the data from leaking. But yeah, we'll show you that on the end.
Perfect. Thank you.
And then just go ahead and play it, John. I think I run the same command, but then for the file that says, the one that's clearly labeled with no data classification in it, showing just no MIP labels present for that file, just comparing it, right? And then go ahead, and the next step is just opening, like I said, I think it's ChatGPT. In this case, same functionality. CyberCrucible doesn't care about which AI tool it is, or if it's coming from a native executable or a browser or anything like this, right? And just trying to access the files and say, analyze this, right? Like tell me what data is in it. And again, this could be for a malicious use case or just a user that's doing things that they shouldn't be doing without necessarily being malicious, right? Just uploading files or things like Copilot scanning your entire disk and trying to access your data, right?
Mm-hmm.
So go ahead and just trying to upload the files here. And first, go to the documents folder and showing just, start with the MIP sensitive data doc and just showing that immediately CyberCrucible blocks it from the kernel. It doesn't matter what user you are, if you're an admin, if you're running something as system or, very privileged, not privileged, CyberCrucible is going to stop it no matter what because it's a policy based on the behavior, not a user, not a whitelist based on access or something, right? And just clicking around to a couple of the other files in the the different documents, same exact thing, until we go to the no data classification file, which is the one that we saw doesn't have the labels,
Now
and it'll just let it go through.
these files are all sitting in your documents folder, not on the network drive.
These are in the documents folder, but CyberCrucible treats it the exact same as if it's a network drive or anything. Yeah.
Even if it's from a SharePoint or Google Drive, OneDrive, it doesn't really matter.
Anything that's CyberCrucible is sitting so low that they don't care so low in the operating system, they don't care what the source is, because to Windows, whether it's streaming or whether it's a file on a disk, a local drive, something like this, it's all the same. So they look at the actual access pattern. They don't care that it's on the C drive or a network map or Active Directory or a OneDrive or whatever it might be.
And if your DSPM does structured and structured data, we can talk to it about running it in the keeping it from AI accessing it in a database, which gets really crazy powerful. That's one of the demos we're gonna end up building around it, is showing.
Yeah, that'll be awesome, John. At some point.
But you got to have the DSPM that can look inside there to classify it, right? So,
that's right.
Like I said, we have our favorites, and then some of them are really good about keeping the grass cut short. Some of them you need special insights to do special.
100%.
So we have like I said, scanner ecosystem. So I think you're picking up what we're putting down. All right, Kyle, I got you. I'm gonna hit play again.
Yeah,
definitely. Yep. Yeah, so this is just, again, showing that it was able to access this file in particular. This one, the MIP label was specifically removed from it to show that, like, if there's no label, then it'll be able to access, not mattering, like, what data is in the file. But, like, the scanner obviously is separate from this. This was me manually removing the label to say, this particular file has no data classification. Watch ChatGPT be able to open it, right? And, of course, it's able to upload it. It's able to analyze it because it's not being blocked from the kernel level, so it's able to do that full file I/O on it, again, regardless of what it is or where it is, because it's based on that ecosystem of the labeling. So next up is going to be the ransomware demo. The ransomware demo I did last because I generally like to cut the network connectivity when I run malware of any kind, even though I know it's going to be stopped. Just, security hygiene, you don't want it to be network connected, right? So I go back to just bringing up my files here, that are the birds. And CyberCrucible does this demo with this particular strain of ransomware for a couple of reasons. They have many demos, and of course, like I said, we can do this in your environment, our environment, live, whatever. They have this demo in particular showing the before and the after and with and without different security tools, showing this is what they do versus this is what CyberCrucible does, right? This particular sample of Hive is the strain of ransomware. Uses, like I said, a process injection technique that was actually, John, you can just play it while I'm talking.
There it goes.
It's actually using a loader. So there's two files there you can see. There's Hive runner, and then there's an encrypted file, which is the actual malware payload, right? The way that this works is because they use the process injection, the runner exe is the loader. that is considered benign by security tools. And those command prompts you see that appeared and disappeared are the malware. So this sample is actually a couple of years old at this point, meaning that you would think every security tool would find it and immediately delete it because it's a known bad sample. But because of that process injection, what it does is it takes the payload, it finds some privileged, trusted process like an SVC host or something on the machine, and it forces that process to do the bad action, meaning that it evades all the sort of traditional scans because it's only in memory, it's only ephemeral, and it's only coming from a trusted source. And what happens here is you can see this admin command prompt that appeared is the malware running. And this is why CyberCrucible likes to run this particular sample, because of the process injection and because of the story of the loader and all the things. But it tells you exactly what it's doing while it's doing it. So it tells you stopping services, deleting shadow copies, killing processes, encrypting files, all these things, which is great for visualization for a demo. So this sample in particular was actually used successfully against a couple of hospital systems over here in the eastern US. And that's how CyberCrucible got a hold of it, because a hospital system came to them and said, we were just taken down by this attack. We saw your marketing, you claim that you can stop 0 days and all these things, prove it, here's the sample. And they sort of kept running with it since, right? So it actually iterates every service running on the machine, backup solutions, antivirus, alert aggregations, including CyberCrucible, and with its admin permissions tries to stop the service. It deletes shadow copies, system restore points, things like this that could be used, by other tools to try to preserve an attack. It goes through again and it kills any remaining processes that might be related to security tools or anything else, again with admin permissions. And then it starts scanning the drive and iterating and encrypting. And by the time you see encrypting files at the end there, the ransomware's already started encrypting the files, or trying to encrypt the files. If this was, a before and after without CyberCrucible, you wouldn't even, as soon as you see that text, all the files are encrypted already. It only takes a couple of seconds, right? Whereas what's happening here is as soon as this malware, even though it's running trusted, even though it's running as administrator, as soon as it starts running and trying to iterate the drive, as soon as it starts accessing and reading the first files, CyberCrucible jumps in and prevents the disk I/O or the network I/O or whatever it might be from actually happening before they even get to the point where they can read or override the files. And this is me just opening them, showing that the files are still fine. This key file at the end here, you can pause it for a sec, John. You can see the first line there of that command prompt is exporting this key file. And this is the RSA public-private key pair. They export the public key. So that, if you were a victim, obviously you're going to pay them, you're going to send them the key pair so they can send you back the key, the private key, right? This gets created, which shows the ransomware is in fact running, right? Like I should say the execution of the ransomware started. This isn't the case of a known signature being prevented, when it's extracted or when you double click on it or anything like that, right? It did actually start executing its payload, but CyberCrucible jumped in and stopped it at the time of data access rather than looking for a signature when the file was first executed, right? So it does actually
the timing.
Yes, same as the AI use case. CyberCrucible jumps in when the data is accessed, not when the user launches a process or something, because they actually care about the behavior of what's going on in the system, not looking for like indicators of compromise or known DLLs or known signatures or things like this, right? So no matter how long we let this sit for, just like John said earlier, this process is essentially frozen in memory. CyberCrucible suspends it and isolates it, where they hollow out the executable instructions and they prevent it from doing anything else, but they don't terminate the process. So that way the attacker, if it's manual or via a C2 or however they're doing it, they think that everything is fine. And that way your security team gets the alerts. They get all the root cause analysis. If there's any process following or injection like happened here, CyberCrucible will show it, show the user that started it, show the process tree of what process began it, the DLLs that are loaded, which endpoint, all of the times, all these sorts of things, and stops it immediately. And notice also the end user here, like John said earlier, doesn't get any big pop-ups like red alerts or anything like this, right? Like the SOC team or whoever's on the other end to receive the alerts on the network side, the security team, they'll get the alerts, they'll get all the root cause, but the end user, who's probably just an employee, they just keep going on with their day-to-day because the computer is still usable and their data is still accessible. Everything stays up. There's no business interruption, no downtime. but the malware is stopped. And this is extremely important, obviously, for users, employees, but especially for OT environments and servers, right? Things like this, where a lot of the attacks will happen directly against like a database server or something like this, right? You don't want the server to go, if the server goes down because an attack was prevented, that's almost as bad as if the attack actually was
Right?
successful, right?
Yeah, you're like down. Joby, did you have a comment or did you say yes?
No, no, no. So it should be more applicable in the critical infrastructure or air gapped system, I believe,
Well,
because mainly
this is the
mainly this
funny thing. Where do the hackers come in? The hackers come in on the edge, and then they move to the servers, right? So it's better putting it on the edge to keep them out there. But yes, ideally you put it in both. And like the servers always have a heavier cadence, but one of our logo referenceable customers is the Juilliard School. I can personally, I'm the vCISO there too, so I'm not oversharing. I'm bragging and selfishly bragging that we did not have an incident since before Thanksgiving to date, and every other school has, especially the ones that got into the protesting and whatever. Like we have a sister school in Beijing, China. We have a pipe to the other side of the Great Firewall of China, and we haven't had anything come through. And I can honestly tell you, like, I selfishly like installed this so I had less to do as the CISO, right? And it works. Like that's where I really get excited about it. Like it's referenceable and actionable against state actors. It's actionable against your own internal force with AI. Like it's awesome.